All right. So this is my third try on this one only, so this is good. In this video, instead of making bar plot and kind of just looking at the most expensive cities through average, what we're going to do today is actually make a correlation matrix. Now we're going to study correlation coefficients and see if there are numeric variables that have a relationship, a predictive relationship. So after that, we're also going to make a scatter plot with a regression line, essentially a line of best fit. And we are going to find a significant relationship today. Um, but I wanted to show you guys a few mistakes that I made when I was doing this code. The reason I want to show the mistakes is because I believe it's very insightful to see where I have made a mistake for when you guys are in the future and you're thinking about how you're going to do your analysis and how you're going to manipulate the data set to do so. Um, think about just the mistakes that you make along the way and learning from them. So that's why you might see some things kind of seem out of the ordinary or out of order. But it will make sense in the end, I assure you. So yeah. I'll also try and talk a little bit slower because I know if you speed up the video, it'll actually allow you to hear me. So I'm trying to do that actively. So same data set that we're using. It's from Kaggle. It's New York housing prices. Um, we're looking at a similar thing. We're kind of just trying to figure out, okay, what am I seeing in this data set and what sort of predictive value does it have? However, the hypothesis is very specific. I believe that we are going to see a positive correlation between price and square footage. And that's under the assumption that, if you want a bigger house, you'll have to pay more money. And that seems very intuitive, and it is. But when you guys are doing more complex analyses, um, maybe with ratings of affect and much more complex ideas, then it'll be very important to still form a hypothesis and, and kind of use that to direct your code. So we're going to get right into it. Because it's the same data set and we're going to be doing a few of the same manipulations to the table. We're going to use the same packages. Um, Pretty much all tidyverse again. It's the best. And then after that, let's see, we're going to add another R code. So again, just telling the computer, hey, this is going to be my working directory throughout the entire Markdown document. Here's the libraries that we're going to use. Sorry, the packages that we're going to use. We're using the library function. And very similarly to how we do pretty much everything else, as we're going to load in this data set. Another thing that we're going to do is we're actually going to call it something special. So let's see, I just need to find the function now. Oh goodness. So what we're going to do is we're actually going to call this read or read. The reason I want to do that is because I want to actually create a variable that is the most original comma separated value. And the reason I do that is because just in case I want to run the analysis a different way, maybe I, did so many sequential functions that the data set looks so much different that I want to restart. This will be nice because it'll allow us to call to the original, data frame that we have. Don't pay attention to those data frames that were up there. We have to rerun this. So yeah, that's why we're going to make kind of an original copy on the computer. So this should be omnipresent throughout the rest of the markdowns, and we're going to be calling to it a few times just because when you make a mistake, sometimes it's nice to just start all over again on kind of the original skeleton, data set. So let's go ahead and assume that I want to look at price of data. I don't necessarily feel as though I need to do the cities, but we're, the city and states, state zips separation. But we're going to do it because there's a reason later on, but essentially I want to have the cities as a column. I want to know what rows are in what city because that could be useful later on. That's why you keep around columns in the data set that might not be valuable to you at that exact moment, um, but could be valuable in the future. And so because we made an kind of an original copy, when we make this, this first function, I actually want to make sure I assign it to a different name. And what this name represents is essentially attempt number one. This is like my first attempt. So now if I make so many mistakes with the separate function and mutate, blah, 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 we can go, just make a new chunk and put ny housing one, and that'll represent your second attempt. You know what I mean? So we can focus, or we can kind of rely on this to be our original copy, and none of the changes that we make following it are going to have any effect in case we wanted to sort of restart, which we are going to do in this video. So my intuition tells me, hey, let's look at the top 5 cities again, and let's see maybe houses in New York, because that was the bar plot that we had made, and New York is by far the most expensive. So we're going to follow my intuition and go ahead and do that. So by doing that, we need to do a very, very similar set of functions that we did for the bar plot, essentially saying, hey, I'd like to see home and house for sale, pull both of these types of rows. Oh goodness, I'm really leaving my data everywhere here. Yeah, so we're gonna, pull everything that we perceive to be a house or a home. And let's just double check and see everything is working. It seemed like we only have house or homes for sale. So I have like multifamily homes and townhouses for sale, which is interesting, and maybe we'll get back into that. But again, I want to see all the houses in New York because I believe that that'll give me a good idea. That being said, let's do a function that only calls or that only pulls or returns houses in New York. And we're sticking with the same name because I want this to sort of represent an attempt. I probably could have put filtered in front of this one as well and this one for consistency reasons, but I'll explain that later. So we're going to pull all of the rows that are in the city of New York, and let's see. Nice. So there's all New York. As you can see, there's only 149, which is kind of a small number when you compare it to the 4,800 that we have. And I think from a data science perspective, that should be a concerning number. But for the case of practice, we're not going to worry about that right now, but I think that goes into my later explanations. So now what we want to do is find the average price and also create a new column. We actually did this in the last video, so I'm not going to go too far into it. So now what we're going to do is essentially the same exact thing as we did in the last video and just say, okay, well, let's see the top 5 houses then. Oopsies. That's only giving me New York because I actually did the New York function over here. So maybe I should not do this yet. That's what we're going to do. We can run this again. Let's see. All right, well, so we need to restart now. I made a mistake in the order of things. And so now my variable is messed up. So what we're going to do is we are going to go back to the original function and rename it. Or you could clear out your data. Sometimes that's a very scary thing to do, and I completely understand. So same process now. Just gonna move through city state, filtering for these. I'm gonna assume that you guys already know sort of what's going on here with all of these functions because we've already covered them. But essentially, what it returns is again, the 5 biggest or the 5 most expensive on average places to buy a house in New York. Now, we're going to continue on, with essentially making a correlation matrix, but I want you guys to think in your head about, what would be the best way of only studying price and square footage. Because right now, I don't think that that's what we're doing, but we're going to continue on so I can show you guys sort of what I was thinking. Now, another thing you're going to have to do before you make a correlation matrix, and let's go ahead and make a new markdown. So one thing that you have to do when you make a matrix is ensure that the entire data frame that you have is only numeric. It's not like you can make a correlation matrix with things that are characters like type and like address. Really what we're looking for is numeric. So property square footage, it's a number. Price, it's a number. So just making sure that all of the columns, we're gonna see the correlations between all of the numeric columns, although those are the two columns that we're going to be specifically looking at. So we need a function that's going to remove all of these non-numeric columns. And that's exactly what this does. It's the select if function. Yeah, and you're using is numeric. So this is something that detects whether or not the variable is numeric. So let's do that. It's also called ny housing underscore num or numeric. So now we're going to go ahead and make the correlation matrix. So remember that this is not a data frame. So we can't just take this and and go straight into plotting and doing other analyses. This is essentially performing the math. So there are a few other functions that we need to do, but it is the core function COR. So you need to specify the data set. And then this right here is interesting. So this is the use argument and complete obs. These are all actually predefined. And what you're saying is only use rows that have a complete case. So maybe you have a row where a participant, you don't have all of that information. What you're telling the computer is if we don't have all of the information on this participant, then don't use it. And that's pretty standard for analysis, unless you have a method of sort of dealing with the missing values, which in this case we do not. In the primals paper, they do. In this case, we do not. So only use complete observations is essentially what that argument is saying. We already ran it, or did we? Yeah, we did. So after that, I want to see it, right? So we're actually gonna turn it into a data frame, and then I'm going to explain to you guys sort of what a lot of the functions within this are doing. So find pairs of columns with a high correlation. This is essentially saying, hey, tell me, what two columns or what pairs of columns have a strong relationship or a strong correlation. And as you can see, we assigned a new variable for the matrix. And that's exactly what we're calling to in this function, which essentially says, hey, take that matrix and turn it into a data frame. And it actually has to go sort of like in a shell, because what you need then is you actually need it in a table. And then after it's in a table, you can then turn it into a data frame. So this function right here is actually very powerful in what it's doing. But the main purpose of it is to put it in the right format for the computer to do the correlation matrix on it. And that needs to be a data frame. Sorry, to do an analysis on it, it needs to be a data frame. It cannot be just a matrix. So that's why that's there. And then the other thing is we are filtering only cases where variable 1, variable 2 do not equal each other. That essentially just means don't include self-correlations. And this is also a very standard thing. What you're going to find in a correlation matrix, if you don't have this, is that it includes pairs where the pair might be price and price. Price and price are always going to have a correlation of 1. So that's actually going to mess up a lot of the numbers downstream. So you're going to find this function a lot of the time, especially when you have something like a table or a matrix that is showing pairs. var1 and var2 essentially just represent those are the pairs that you'll find. So you're telling the computer, hey, whenever price is being correlated with price, take that out. Now what we're doing is in this next function is also a filter function, and we're using the pipeline operators. Sweet. So what you're using in this filter function is you're saying, I only want you to filter out and return the cases in which the correlation is stronger than 0.7. As you guys probably already know, correlation exists on a spectrum of -1.0 to 1.0, positive 1.0. Anything above 0.5, 0.8 those are considered meaningful and significant correlations. So essentially what I'm telling the computer is filter out only the times in which the correlation is stronger than 0.7. And what you're doing with this ABS function is you're actually saying absolute value. So this is also kind of holding in regard the fact that it could be a negative relationship or a negative correlation. So it's just going to return strong relationships. And then we're also using the arrange function to say, hey, if you find three of them, put the strongest correlation first, second strongest next, essentially just putting it in order. So yeah, that's what we're doing with that. Let's go ahead and run it. And um, what we're going to find here, let's use the print function because I think that probably does a better job. So what you're going to find here is interesting. It didn't return price and square footage, and we thought that there was going to be a relationship there. In fact, you can even lower the threshold for which it returns uh, correlations to, let's say, 0.4, which is not nothing, but it's definitely less than what we were doing before. And we might expect to see price and square footage, but we don't. We still don't. And I was thinking about this, and I was kind of wrestling with it because I knew for a fact that there was at least some relationship there. Um, and this was earlier today, and I was thinking about it, and I was thinking, okay, well, what are we looking at right now? What we're looking at is houses in New York, and we're looking at only houses in New York City. More specifically, we're looking at townhouses, multifamily homes. I don't feel that that's like a very consistent or representative population of houses to look at in order to reasonably observe price and square footage. Because what you have in New York City, is maybe, I mean, how many houses do you know of in New York City? So thinking about that, I was thinking about it and I thought, okay, well, there's probably, $60 million penthouses and, maybe there's other much smaller homes and they probably belong to much different, socioeconomic populations. And so I don't know that that's a good way of actually trying to understand the relationship between price and square footage. That could be useful if you're trying to, maybe observe the differences in other variables with regard to only being in New York City. But I realized if I want to look at houses and the relationship between price um, and square footage, I want to find a place that has a lot of just houses, so suburban areas. And not only that, but I also want to look at um, uh, I also want to look at a data set that does not have any like townhouses or multifamily. I just want houses. And essentially what I'm trying to do here is I'm trying to find a more consistent population of subjects in order to measure two variables and their correlations. That might be counterintuitive. Like, why are we trying to find a more like non-diverse sample? The reason is because we're not actually measuring the sample, we're measuring variables that affect that sample. So all that to say is we are actually going to look at not New York, but Staten Island, which is a suburban city in New York. The reason I picked this is because Staten Island has much more areas where it's just kind of a suburban neighborhood. So you have kind of cookie cutter homes. And the reason I like that sample is because it's very consistent. So I know that price and square footage are going to be consistently represented in that data set. Now that is going to give me a much more representative correlation coefficient. And this is a realization that I made at the library, and it was quite the victory. So what we're going to do is we're going to create a new chunk here. And this chunk, we're going to use a function, read CSV. And as you can see, we are calling to the original copy. I don't know if you guys remember, but we made an original copy of NY housing, and it had underscore red at the end. And the reason we're doing that is because if I were to just tell it to read NY housing, that data frame has been manipulated a lot. I've already done a lot of things to it that are going to have major effects downstream. So that's why we're calling on our original kind of skeleton data frame, we'll call it. And I'm also performing, similar cleaning on it. And this is just in case I did not do it up here. And that is indeed the case. So, this doesn't even have city-state zip, a city-state zip column in it, this data frame right here. So we have to kind of redo all of it, except it's going to be SI housing, Staten Island housing, not New York housing. So that is why I did, the syntax that I did earlier, and I told you I would explain it. There it is. But yeah, this is like our attempt number 2, I guess you could say. So again, we're gonna have to pull the cities out because we need to identify which ones are in Staten Island. So these are the exact same functions we've already done a few times now, so I'm not gonna go too deep into them, but we're just doing them with a different sort of objective. This next function is interesting. So there's a few things different here. You're gonna see I'm gonna copy and paste these 2 functions and actually put them right on top of each other just so you could see. I thought about the function where I was pulling out houses and homes, and I was trying to look at, a very specific type of property. But I thought that that wasn't specific enough because what we had in this data set was townhomes and multifamily homes. I just want house for sale, because when I go to the original document, what you'll see is there is a unique value called just house for sale. And if I'm going to keep the same idea of a consistent population with the Staten Island and the other things, then I want to also keep the same sort of idea for the type of property. I want a consistent population to measure the variables within. So that is why, instead of kind of operating these 2 together, I only did one, and it's called house for sale. And you'll notice that the ignore case function is actually set to false. And that is because the default on the string detect function is it's not going to care about whether it's capital or not. In this case, I actually do want it to care, whether or not it's capital. And that's because what we have in the original data frame is we have a data or a unique variable called townhouse for sale, and it's got a lowercase h. So I'm really wanting just these. There's many other ways of doing this. Excited to see if you guys have any other ways of solving that problem. But yeah, that's why this function looks a little bit different. And that's why I really wanted to show you guys the mistake that I made earlier today. And so we're gonna run that function. So now if we go ahead and look at what we have as housing, you'll notice that that is indeed what we have. We have just house for sale. So what you'll also notice is that it's not only city or houses in the city of Staten Island. That's because we actually haven't performed that function yet. We're doing sort of a restart. So that is where this next one comes in. So this is an interesting one because what I'm doing with this particular function is I'm actually doing 2 at the same time, and I want to demonstrate the power of the pipeline operator with this function. So you'll notice up here, what I did was I had actually found only the numeric rows up here, and I did it right before making the correlation matrix for the New York housing. And so what I wanted to do was I wanted to actually parlay it with a different function, and that was the filtering by Staten Island, just to show that we can do both of these at the same time. And then what you'll notice within this filter function is that I'm using an in operator. That's just essentially telling the computer, find this within this. So find Staten Island within the city column within filtered Staten Island housing. So this is a neat little function because it does, a lot of different things at the same time. So now let's look at it now. What you'll notice is that it's only got numeric columns. It doesn't even have the city anymore, but we know for a fact that these are only Staten Island homes. And the reason we know that is because we used this function. Now, it might be good to do this separately. In fact, I would suggest that you're just gonna have to trust me that that is only houses in Staten Island. I assure you it is. Um, but the reason we're taking out all of the non-numeric columns is because we're doing a correlation matrix, and that's the fun part. So similar to how we did it earlier, we are going to actually use the core function now. And again, this is not going to give us a data frame. It's not going to give us anything that's like visual as a result, but it's going to perform the math. So what we need to do at that point is continue on. If you didn't get any errors, and you can see that there is indeed a correlation matrix, or there's a matrix there, seeing some big numbers, so that's exciting. We still need to make it a data frame. So you're going to assign it to a new variable, core, correlation, housing, Staten Island. As data frame is a neat function that I believe we used earlier, and then as table. And you might be able to guess, but what these functions are doing is essentially saying, take this data set and turn it into this format. And this is only going to work if your data set follows, the proper sort of conditions that it requires. And we can get more into that, and I can link you guys to some good resources that'll show you why that's important. Again, we're filtering for self-correlation values because that will mess up kind of the whole data set. And then, we're also filtering for only very strong relationships, and they can be both negative and positive because we're using the absolute function. After that, we're using the arrange function to show us in descending order. So that means the top one is going to be the highest or the strongest relationship. And all right, well, I guess it's time to actually view it. Let's see if that runs, and it does. So now let's print. The print function obviously is just for viewing whatever you just accomplished, or you can do view. And aha, this was a beautiful moment when I found this. So as you can see, this is our original hypothesis. I don't know if you can remember from the very beginning, but I think that price and square footage will be positively correlated under the assumption that a bigger house will cost more money. So obviously we had to kind of go on a journey to get here, but what we found is there is indeed a very strong positive correlation between price and property square foot. We kind of just had to make some mistakes and think about the data set that we were looking at, and think about the question we're asking, and all of the various functions, manipulations, and cleaning that needs to happen for us to find to find that analysis or to find that observation. So it's not just going to end there. We're actually going to make a really cool plot. It's going to be the scatter plot with a regression line. And the way in which we do that is first, we're going to mutate. So what we're going to do is with this function actually, guys, is you'll notice on the bar plot that we had made that the price number kind of has such large values that it messes up the spacing on our graph. So what I wanted to do was just have the price values now, instead of it being this big, big number. Essentially, we're going to divide it by 1,000,000. And so now when I plot it, all I need to do is go on the Y label and say, hey, by the way, this is in millions. Because obviously the price of a New York home is not going to be $6. It's going to be 6 million. So I think that, that's intuitive enough for me to make this sort of mutation. And so that's why I did it. The reason why I did it right before I made the correlation matrix is just in case that was going to mess up any analyses. I don't believe that is the case. But I do like to be on the side of conservative when it comes to manipulating the data set. So now what we're doing, what you'll notice in this one, in this data set, is that we have, oopsies, maybe that was the wrong one. I don't want to confuse myself here. Okay, so what we're doing with this one right here is we're saying, I'd like to assign these variables. That just kind of makes the correlation simpler to make at the very end. So that really shouldn't be, too big of an issue. So after that, let's run that, and then let's run that. just so that we don't have to like write out this whole thing when we actually do the plot. Speaking of plot, we are using ggplot. So now what you're going to see in here is, this looks much different than the bar plot that we made. However, the function is still ggplot. So a lot of what happens is actually, sort of the functions that follow. And so to start, what we're doing is we're calling to the data frame. This is standard for all ggplots. And then we're also using the aesthetic function, essentially telling the computer, this is how I want you to fill the contents of my plot, whatever it is going to be, because we have not determined it at that point. But what we can tell the computer is essentially what the X and Y are going to be, as well as some other information, but let's stick to X and Y. GM point is just saying, I'd like to make a scatter plot. So it's going to be just a bunch of points on an XY graph. GM smooth. So what this does is it adds a line to your graph, and this is a very versatile function. And in this particular case, we're putting in a regression line, so a line of best fit. And then within that, that is the method argument that you're using to say I'd like to do. And this is actually predefined. So this is part of the function, or part of the package, sorry. You need to specify that you'd like to do a linear regression, or I'm sorry, a regression line. And then after that, the call, which can sometimes refer to columns, is actually just color. And we want it to be red. And you'll notice that red actually pops up, so that's cool. GG title is just the title of the entire plot. XLab, I'm assuming you know what that is. Price in millions, boom. Let's try it. All right. So, I mean, this is just an absolutely beautiful plot, in my opinion, because it, represents a very strong relationship. This isn't always going to be the case, but I think as far as practicing, guys, it's probably best for us to look at a strong positive relationship first. Maybe we can look at some negative relationships, but I think that we're going to get more so into time series plots. It's just cool because we got to learn how to make a new type of plot, and that is a scatter plot. Not only did we learn that, but we learned how to insert a regression line in, in order to best visualize a correlation that we had calculated earlier. So I hope you guys learned something from this. Definitely give me some feedback. And yeah.